All right, welcome to this portion of Advanced Anatomy and Physiology, and in this unit, this is the lab unit, Unit 6 on musculoskeletal fitness and assessment along with body composition. This one was not recorded in front of a classroom, so we'll just kind of go through this as a voiceover PowerPoint with you. There are I believe two sections in your lab packet that this is going to cover over, two individual sections. So yes, musculoskeletal fitness and assessment, and then also body composition. So there are some pages to review this material in, but we'll go through some of the details right here. So lab objective 1, when we start with musculoskeletal fitness and assessment, is flexibility. And so we've defined flexibility, which is the ability of a joint to move freely through its full range of motion. And so one of the things that we do in the lab, which you won't be able to do at home, is a trunk flexibility test, which looks at the flexibility of your back, hips, and legs. And so there is a table in your lab packet, I believe, that shows kind of what's normal and with the flexibility, if you will, as far as if you did a sit and reach test is basically what we do in lab. So obviously this is kind of the downfall with online, you don't get that hands-on component of a flexibility test. So basically you would have somebody sit down with their buttocks on the ground and their legs straight out and their feet pressed flat against a device basically, and they would put two hands in front of them and reach as far forward, and basically they're pushing this little thing forward, which tells them how far they've actually were able to stretch, and that then would correlate to a flexibility score, if you will. So obviously you won't be able to do that, but what we do want to talk about, you should be able to define what flexibility is and also what are the benefits of flexibility, which one is good posture. You tend to be more flexible with your soft tissue and be able to create a better posture with yourself. With that flexibility, it also increases max ventilation because now your muscles are more flexible around your rib cage and your diaphragm area, which helps increase your breathing and hence max ventilation. Flexibility will also decrease muscle soreness and injury. Obviously when you guys may exercise, you're going to do some stretching and help with the flexibility to decrease your muscle soreness, but also doing that pre and post will help with injury as well. And obviously good mobility, being able to bend down and not, pull a muscle, and different motor skills such as that. Factors that decrease flexibility would be collagen cross-linking. So this happens when we don't stretch or flex. This is the collagen, which is in some of your soft tissue, will start to cross-link and make it more difficult for you to have flexibility. And inadequate stretching, obviously if you're not stretching on a regular basis, this will also happen, and lack of activity as well. Objective 2, we look at muscle strength, which the definition is the greatest amount of force that an optimal stretched muscle can exert following a maximal stimulus supplied at high frequency. It's kind of a mouthful there. And so what we're looking at is a stimulus that is being applied at a high frequency that would create a very strong force within our muscles. And so improving our strength, we would do resistance training or weight training. There are two different types of this resistance training that we look at, which is isotonic versus isometric. So you need to know the difference between these. Isotonic resistance training is when the weight of something stays the same, but the length of your muscle changes. So let me repeat that. Isotonic resistance is when the weight stays the same but the length of your muscle changes. So an example of this would be if you had a set of dumbbells in your hand and they were 25 pounds apiece. That weight isn't going to change unless you set them down and grab a new weight, right? But your muscle, every time you curl up, your bicep muscle is changing its length. So that's considered an isotonic resistance training. Isometric is the opposite of that, where the weight stays the same, or the weight changes, the weight changes, but the length of the muscle stays the same. So imagine if you took your two palms right now, if you will, and you put them together and you started to push inward against those two palms of your hand. So what's happening is your weight or your pressure is changing depending on how you do that, because you could press really hard or you could lighten it up, but your bicep muscle isn't changing its length. So that's an isometric resistance training, or what we call isometric contraction. Another example of isometric contraction is if you did planks, where you're off the ground, you got your tiptoes up and you got your forearms on the ground, and you're just holding that position, and your core muscles are tightening up, but they're not changing in their length. But the longer you do that, that pressure, that weight starts to increase over time. So advantage of improving the strength would be improving your metabolic metabolism, if you will. The more energy you're expending, the more metabolism you're generating. Obviously, athletic performance. You're increasing your muscle mass, lean body mass, which will help with your athletic performance. Basically, there's a lot of changes that we'll talk more about in lecture, but athletic performance would be like more mitochondria, which produce more ATP. There's more muscle mass. Also, when you're resistance training, as long as you're doing it correctly, you have a reduction in injury potentially as well. Now, one of the things that creates this increase in muscle strength is the more cross bridges that form in your muscles. And so if you remember back to general A&P, or if you've already watched the lecture on muscle physiology, we talked about the actin-myosin cross-bridging that was taking place. So the more of those you have, the increased strength you have, but also the size of the muscle matters, how many muscle fibers are being stimulated as well, the rest length that you may have in between sets of activities, how frequent that you're doing this is, like it says up here, high frequency. So there's a lot of things that go into play with this muscle strength. Endurance is the ability to repeatedly exert a submax force. So that's kind of key, submax, not a max. You wouldn't want to start out a marathon running max out because you wouldn't make it, but a submax force over a time period. So increasing endurance, such as biking, swimming, running, jogging, brisk walking, you notice all of these are longer lasting activities, whereas the last one with strength was more a short bout of activity and more with weights than anything. So it's really, with endurance, we tend to increase the ability to recycle ATP better and maximize ATP production better with this, which will allow us to go longer distances and increase our endurance. So with advantages of endurance, we look at muscle efficiency. It's more efficient. It can create a lot more ATP. We can recycle ATP better. There's an increase in metabolism. There's an increased resistance to fatigue. So like I said, these people can go a long period of time. So you think about if you've ever started an exercise program. Let's say you start by running 2 blocks, and the next day you go 4, and the next thing you know, you're doing a mile, and then 2 miles, and you're increasing that endurance, and that's happening over time. But what's really happening here is that your muscles becoming more efficient. There's a lot of physiological changes that are taking place that I'm not going to really get into all of that here necessarily, but we'll probably get into that more in the lecture component of it. So this is where there's a disadvantage of having an online course. So normally in our lab we would do activities that would assess all of these components. We would do a trunk flexibility sit and reach test. We would do a muscle strength test using a hand grip. We would do a bench press test as well. We would also, if I'm not mistaken, maybe that might be in a different lab, but I think we do like a 1 mile walk test too. I think that's in the cardiovascular system. But you do want to know the measures for each of these, but being that you are not in class necessarily, I'm not going to hold you to those what we would consider to be normal for these tests, if you will. I just feel like without you actually seeing and seeing the test, it doesn't really resonate very well. So you don't have to worry about what the measures would be for each, but you do want to know about the information that I just provided you in the past slides. So now we're going to switch over to body composition, which is the second component to this lab. And the first thing that we do in body composition, objective 1 there, is the body weight. And so the definition of body weight is the weight of an individual in pounds. Now in the hospital we like to use kilos as well, kilograms as well. So just something to consider, because when you are in the hospital they typically use kilos more than they do pounds. Now, body weight is different than body composition, so the weight is different than what it's actually made up of. And so body composition is, what is the body made up of? Is it lean body mass? Is it body fat? And how much of each of that would it be? And then we start getting into some percentages that you will have to know here in just a little bit. So, you might have a big person, a lot of weight, but they may have lots of lean body mass, where on the other hand, you might have a big person with a lot of weight who has a lot of body fat. So, I don't really want to pick on anybody, but, let's just look at like Arnold Schwarzenegger. He's a really big guy. He's got a lot of weight. In his prime, he had a lot of lean body mass. And now as he's aging, he's losing a lot of that lean body mass. He's still a big guy, but he's probably got a little bit more body fat than he does lean body mass. So just as an example, when you look at somebody, we don't want to always assume that they're overweight because of fat. It could be because of lean body mass. Did I say that right? Okay, good. Body mass index, or BMI, is a really important indicator to determine obesity based on weight relative to height. So BMI is kind of a buzzword you hear a lot in the hospitals and other different facilities and things like that. And so the way that you figure out BMI, there's a mathematical formula, which is weight in kilos divided by height meters squared. You will see this, I believe, on page 43. There is that formula there, and you may be asked to figure out the BMI. You will be provided a calculator on Respondus Lockdown, if you will, that will allow you to do that too. But when we look at this, what I'm really interested that you know in your lab packet is what is in bold where it says desirable. So if you look in your lab packet, you'll see these, but this is the one that I want you to know right here. I don't care that you, let me go back. I don't care that you know the numbers by heart for overweight and obesity, but what would you want your patient desirably be in this BMI? This is a number, so if you could have your patient in this number 20 to 25, this is what you would want. So maybe what would be kind of neat for you to do is just take your body weight in kilograms, so 1 pound is 2.2 kilos, and divide it by your height in meters square, and determine where you're at, and just see kind of where do you fall, desirable, overweight, or obese. Now, with this, though, there's a problem with BMI. It doesn't take into consideration body composition. So it just says, okay, you weigh this much, you're this tall, and here's a number, right? But it doesn't say whether you're short and you have either muscle or fat, or if you're really tall, whether you have muscle or fat. So there's some limitations. It's a good guideline to go by, but it really doesn't tell the whole story, right? Somebody could be really short and have a lot of muscle, and you might say, oh my goodness, he's obese, and you might say, but he's got the good kind of weight, right? And so it's just something to consider, okay? Now, with that being said, where do we actually find our fat? And most of it, 50% of it, is underneath the skin. And then we have a lot around our visceral area, which is our organs. But we don't want a lot around our organs. That can actually cause a problem for our organs, like such as your heart. People have fat hearts, or they have fatty livers. They have too much fat around it. So like, let's say the heart, you had a whole bunch of fat around it. The heart would have a really hard time contracting, because it has this extra weight on it. But 50% of it's underneath our skin. Okay, it's our insulation, right? So when we look at percentage body weight and fat, I also want you to go to your lab packet and look at what is desirable for male and female here. This is what you're going to be potentially quizzed on. So male, the desired body weight in fat should be 8 to 15% of the male, and for the female, 13 to 25%. Just want to make sure they didn't change that. Sometimes they do. 13 to 23%, excuse me, for females, 13 to 23%. So look at that up in your lab packet. So the question is then, how do we actually assess body fat? Now this would be another thing that you would do if you had lab face-to-face, which is we would assess it by doing skin fold thickness, girth measurements, and bioelectrical impedance. So when we look at skin folds, we would do skin fold areas for male and female differently in 3 different areas of our body. We would take 3 samples, if you will, 3 measures, and then take an average of each one of those and then it would be put into a formula, and then we would get a percentage body fat based on that. Being that you don't have access to skin fold calipers, I'm not going to require that you know that. Girth measurements then are really it's basically looking at the percentage of fat underneath the skin as well. And so we have different areas of sites for this, and you can see this in your lab packet. For males, we look at the waist and the wrist, and for the females, we look at the mid upper arm and the widest point around their hip/buttocks area, along with their wrist as well. Those measurements would again then be put into a formula. And then our last one is bioelectrical impedance, which is measuring the current that's flowing through your body. So you'd have this device that you'd more than likely hang on, at least we do, or you stand on something too, and it would run a current through your body, and then if it would run into fat, let's say, that would be an impedance for it, and so then it would start to kind of calculate or get a measurement of how much body fat you have. There is a significant error rate in bioelectrical impedance. There can be an error rate in all of these. Could like skin folds and girth measurements could be a user error. I've seen that. Right? Bioelectrical impedance is more of a device error rate. So you have to remember there is going to be an error rate here, give or take, so it won't be dead on exactly. In order to really truly assess like body fat and things like that, like an underwater water test is actually the best. Health risks for being overweight or obese, wear and tear on your joints, all that weight on them, arthritis, increased workload on the heart, we were kind of talking about that, right? Increase in LDL or your lipids, your bad lipids, that would lead to atherosclerosis or coronary artery disease, CAD, which would then, as you see, MI, myocardial infarction, which is a heart attack. CVA is a cerebral vascular accident, probably better known as a stroke. You have hypertension, which is high blood pressure. Compromised airway, such as like sleep apnea. Type 2 diabetes is really big, and then we know that obesity is linked to cancer such as breast, prostate, colon, things like that. Okay, so this is again where we're at here, where you wouldn't actually perform these because you're at home. There are 2 methods of calculating BMI. The one I gave you was the mathematical formula. We also have like this sheet that has the BMI, and you do this. You just look at your height and your weight, and then do a cross each other, and then it like gives you this BMI, which is a really easy way to do it, much easier than calculating it. But go ahead and give a calculation a try real quick, and then we would do the 3 methods of calculating percentage body fat, which you will not be doing. You don't have these devices, you can't do that. And then the last thing we do is distribution of fat, which is the waist to hip ratio. So you take a waist measurement compared to the hip. So the hip is the widest part, and then the waist is actually about 2 fingers above your belly button. So your waist isn't where you think it is. It's not where your belt line is. It's much higher than that. So you take the difference between the widest part of your hips and the waist, which again is 2 fingers above the belly button. And then that would give you this waist to hip differential. And so apple versus pear, right? So typically females tend to be more pear-like, where they're a little wider down at the bottom, where males are a little bit more apple, where they're wider around the midsection. So that's typically what we see. And so, that's certainly something you can look at in your lab packet as well. So this should get you caught up for these 2 musculoskeletal fitness assessment and body composition lab. And if you have any questions, let me know.